All right, guys, your quiz is on Thursday. It's 15 questions. It's going to say factor completely. Anything that we have talked about is fair game, so you have to have some sort of system. What do we look for every single time we start factoring? GCF. A lot of you lost points on your test because you didn't take out the GCF and told me it was already completely factored. Everything factored nicely on your test. You just missed the GCF. So when I look at number 1, 5x cubed minus 20x, what can I take out? 5x. Okay, when I take out that 5x, guys, does it just completely disappear? No, some of you did that. You took it out like this, you divided it out, but then didn't include it anywhere else in the problem. So you did not factor it completely. When you take out the 5x, you're left with x squared what? Minus 4. You leave it there, that's halfway done. Always see if you can simplify more. What are you left with here? There's 2 terms. There's a minus sign in the middle. What is it? Difference of squares. Good. So it's 5x. What times what gives me x squared? X and x. What times what gives me 4? 2 and 2. And what are the signs going to be in the parentheses? 1 plus, 1 minus. Does it matter where it goes? No. So when you guys go to attempt these problems, have some sort of plan, because there's not going to be anything that the computation is so big, you're multiplying 3 and 4 digit numbers. It's going to be basic computation that you have to think through. It's not going to just jump out at you super easy. If you don't like the different letters, you don't like S and T and R and all that, change everything to X and Y. God bless you. Go ahead and rewrite everything as X's and Y's. I don't care. But let's look at number 3. All right, first thing we look for. GCF, okay? Is there a GCF? No. So now we say, okay, how many terms are there? 2. Is this difference of squares or some are difference of cubes? Yes, difference because there's a minus sign in the middle. God bless you. What times what will give you 81s to the 4th? Say it again. 9s squared. Good. 9s squared. And 9s squared. What times what's going to give you 16t to the 8th? 4t to the 4th and 4t to the 4th. So my 2 parentheses are 9s squared plus 4t to the 4th, 9s squared minus 4t to the 4th. That's halfway done. Continue to ask yourself, 2 terms left. Do I have difference of squares? Can I break down 9s squared plus 4t to the 4th? No, that's not the difference. It has to be a minus sign. Can I break down 9s squared minus 4t to the 4th? Yes. What times what gives me 9s squared? 3s and 3s. Perfect. What times what is going to give me 4t to the 4th? 2t squared and 2t squared. So my parentheses are 3s plus 2t squared, 3s minus 2t squared. Again, you want to change the plus and minus in the 3s and the 2t squared, that's fine. But you have to factor completely. It means break every single thing down. All right, God bless you. Scoot along to number 5. First thing we look for. GCF. Good. Is there a GCF? No. So now we say, okay, how many terms? I don't have 2 terms. I have how many? 3. How do we factor a trinomial? A times what? A times C. Okay, now a lot of us do this in different ways, which is fine. I'll do it the way that I showed you guys, and I'll do it the grouping way. If there's another method you have that works for you, perfect. But you guys have to figure out what works. Yes, sir.
I know that when we do the fact, or when we did like the previous one, it was you only break up the one with the negative symbol. And I've been doing it like that, but like maybe I skipped something. Is there a reason why we don't break down the positive one?
Because it's an imaginary solution. Because let me come back to that video at the end. I'll show you why.
Okay.
I'll mathematically show you why when you multiply it out, you don't get that. What's up?
Well, I'm good at guessing and checking, but how do I show my work?
I mean, the least you could do is say 3 times negative 4 is negative 12. You need to get in the habit, Dylan, of showing work because we're still in like basic stuff. As we get into starting Friday's lesson, you're not going to be able to do everything in your head. But, I mean, the least you could do is show me that you multiply A and C. So I need factors of negative 12 that multiply to give me negative 12 and add to give me 4. What would that be? Positive 6 and negative 2. All right, so the way that I do it is I write my 2 parentheses, put my x in the front, and I'm going to put my 2 factors in, my plus 6 and my minus 2. But since the a term is not 1, it's 3, I'm going to divide both factors by 3. And then I say, okay, does 6 divide by 3 nice and pretty? Yes, this becomes x plus 2, right? Does 2 divide by 3 nice and pretty? No, so 3 would become the coefficient here. So it's 3x minus 2. The way that you would do it with the grouping method, if you do guess and check, then do guess and check. That's just using your brain. But the way you do grouping is you would say, okay, I have 3x squared. I'm going to say plus 6x because it's a positive 6. Minus 2x because it's a negative 2. And then you end with the last term. And then you group. Look at the first two. What can I take out of 3x squared and 6x? 3x. And what am I left with? X plus 2. Okay, what can I take out of negative 2x and negative 4? And what am I left with? X plus 2. So here's the new GCF. X plus 2. And the leftover gets its own parenthesis, which is 3x minus 2. Is that the same thing that we got here? Yeah. Either way, does not matter. But how do I know when I go to turn this in that this is correct? What can I do to check? Foil it. If you guys have time at the end, go back, foil it out, make sure that your signs are correct, all that stuff. Some of you will catch little errors by just going back to check. Questions? All right, let's go to number 7. Again, this is like, it's 30 questions. I just took pictures of the ones I wanted to do. GCF. Yes or no? No, okay. So we multiply what, since it's a trinomial? 2 and 3. 2 times 3 is 6. What are the factors of 6 that multiply to give me 6 but add to give me 5? Plus 3 and plus 2. All right, what do I do with my a term? I divide here. So what happens? What's my first parenthesis become? 2x plus 3. Good. What's my second parenthesis? X plus 1. Again, if you do the grouping method, it would be 2x squared. Our factors were 3 and 2, so plus 3x plus 2x plus 3, and then you group. Take out the GCF. What can you take out of 2x squared and 3x? What can you take out of 2x squared and 3x? X. So we're left with 2x plus 3. What can we take out of 2x plus 3? What can I divide out? A positive 1. So here's your new GCF right there. 2x plus 3. And then the leftover gets its own parenthesis. X plus 1.
For the first one, how did you get the 2x plus 3?
When you divide it here, this becomes your coefficient. If it doesn't divide out evenly, that becomes your coefficient.
All right.
You're just taking out the GCF in a different spot in the problem.
All right.
Doing the same thing. Yeah.
Could you scroll up a little bit too?
All right, let's look at something like number 8, GCF. Yes or no, GCF? Okay. So is this the difference of perfect squares? Nope. It's not. It's a plus sign.
Sum of cubes.
2 terms. It is the sum of cubes. Okay. Some of you guys, just a little side note here. You had something like this on your quiz or your test. Say.
I think it was 24.
There was a bunch of different ones. But some of you didn't take out anything, just told me it was already factored. Some of you just took out a GCF. You've got to factor completely. So if you have something like this, it's super basic. I use A's and B's. You can use U and V, whatever. But what is your A term? What times itself 3 times gives you x cubed? X. What times itself 3 times gives you 27? 3. You have now discovered everything that needs to go in the formula. You can write the formula out from the beginning. What does my first parenthesis look like? Since this is x cubed plus 27.
X plus 3.
X plus 3. Perfect. Now think about how your pattern's going to work out. Your first term and your last term are squared. That means they're both what kind of numbers? If a number is squared, it has to be what? Positive. So there's going to be a plus sign right here.
X squared.
What do I know this first sign? In the second parenthesis, what's the first sign going to be? If this is a plus sign here, what's this one? It's opposites. Perfect. So now what's the pattern? X squared. You square the first term. You multiply the first and second, and then what? That's it. And this problem here, which was one of the versions on the test, what would you do? GCF first. What do you take out? Negative 3. You're left with x cubed, what? Mm-hmm. Some of you left it just like that. It's the difference of cubes. What's your A term? X. What's your B term? 2. So this would be negative 3 times x minus 2, x squared plus 2x plus 4. This is just a different problem. Yeah, it's your GCF out in front. So it's important, guys, you've got to find the GCF first. If you don't, you're going to get to a problem and be like, oh, it can't be factored, and it can be. So just make sure you're doing that. All right, let's look at something like 9. GCF. Okay, do you see that we can take out a number and a letter from this mess that we have here? What number can you take out of all three?
2.
A 2, good. What letter can you take out of all three? A squared. Again, write it out in front, and if you need to write it under here so we don't make a silly mistake, do so. What's 24 divided by 2? 12, and then I have a squared, perfect. What's 10 divided by 2?
5.
So 5, that looks like an S. A, B, correct? And then I have what?
Negative 2.
Minus 2b squared. Okay, this problem's a tad bit different because it has 2 different letters. No big deal. Your 2a is staying here, 2a squared, with your answer. Rewrite it down at the bottom if you need to so you don't forget. So I look inside my parenthesis here. I have a trinomial. How do we factor a trinomial? Multiply a and c. So the magic number is negative 24. What are the factors of negative 24 that multiply to give me negative 24 but add to give me 5? 8 and negative 3. Okay, I'm going to do this my way. If you want to do the grouping way, fine. But notice, guys, everybody with me? What letter is in the front of the parenthesis? A. What letter is in the back of the parenthesis? Right? I have a b squared, so you have to account for both of those. There's no way to get the ab in the middle unless you have the letter in the front and the letter in the back. So now we talk about our factors. You guys told me it was positive 8 and a negative 3. Agreed? All right, one more step. What do I have to do since my a term is not 1? Divide both by what?
2a.
No, we already took the 2a squared's already factored out. 12, yeah. Now in this case, guys, neither of these divide pretty. Is that okay? Yes, you just simplify the fraction. What number goes into both 8 and 12? 4. So this would become a 2, and this would become a what? Okay. What number goes into both 3 and 12? 3. So this becomes a 1, and this becomes a what? 4. Our denominators become coefficients. So your answer is 2a squared times, what's my first parenthesis? 3a plus 2b. What's my second parenthesis? 4a minus 1b. Do I have to put the 1 in front of b? No. Can I if I want to? Yes. Now, you can use the grouping method if you want to. I'll write it over here so you guys can see it. It's 2a squared. So then you would start off with 12a squared plus 8ab minus 3ab, and then you end with minus 2b squared. And then you group. What can you take out of the first two? What can you take out of the second two? And it'll work out nicely. Whichever way you would like to do, that's fine, but you will come out with this answer. Again, if you came out with this answer, how can you pat yourself on the back and say, oh, good, I got it right? You just foil it. Foil it back, and you should get your original up here. Yep.
How did you get the coefficients for the first time?
From my...
I just don't understand.
Okay. So do you see where we got the 8 and 3 from? Negative 24 is positive 8, negative 3. So I put the 8, positive 8 here, negative 3 here. And then I divided by the a term, which was 12. And then I just simplified the fraction. 8 and 12 are both divisible by 4.
So whatever the denominator is.
And then the denominator becomes the coefficient. It's the exact same thing as the grouping, but instead of taking the GCF out like in the front, it just kind of divides out within the problem. Yeah.
Which method would you think is more efficient for long wrestling?
Just depends on how your brain works better.
Can you do the grouping?
Sure. Want to finish this one? Okay. What can I take out of my 2a squared is still here? So what can I take out of both 12a squared and 8a? B. I could take out a 4, right? So if I divide out of 4a, do you agree it's 4a? Okay, so I'd be left with, I'm going to take out the 4a. So what am I left with? What's 12 divided by 4? 3a. And then what's 8? What am I going to be left with here? Plus or minus? Plus, okay, so plus 2b. So in my second set of parentheses, what can I take out? It leads with a negative, so what am I going to take out? Say it again. A negative b, agreed. So then I'm left with 3a plus what? 2b? Oh, I hate b's. So I still have my 2a squared out here. Do you see, Priscilla, my new GCF? It's 3a plus 2b. And then my leftovers get their own parentheses, so 4a minus 1b. Same thing. Just depends on how, some of you were taught that way from the beginning, so it's just been ingrained in you. Some of you just have a tough time with the guess and check, so maybe the other way is easier, whatever. All right, scooting along, we got some more to do. What's the first thing we look for? GCF. Is there a GCF, my friends? No? All right, so is this the difference of perfect squares? No, it's the difference of what? Cubes, okay? So identify if you want to use A and B, if you want to use U and V, it doesn't matter. But what is your first term? What times what gives you M cubed? M. What times what gives you 64? 4. Good. Don't worry about the negative because if you, and the end, sorry. Don't worry about the negative because if you use the pattern correctly, the signs will work themselves out. So my first parenthesis is M minus 4n. Whatever sign you start off with, that's your first sign. Then on the inside, M squared plus, good, it's the opposite of the first one. So what would this be? 4mn. And then, guys, remember, when you square this second term, that 2 goes to the 4 and to the n, correct? So it becomes plus 16n squared. Remember, if there is a coefficient in front of the variable, the squared goes to both the number and the letter. You guys with me? Okay, all right. All right, 15. GCF. No, okay. 4 terms. When we have 4 terms, how do we start? We group first 2 and the second 2. Remember, keep that sign with that term. If it's negative, keep it negative. So what can I take out of u squared minus 3uv? I can take out a u. Perfect. So I'm left with u minus 3v. What am I going to take out of negative 6uw? Good. Negative. We lead with a negative. Take it out. So negative. And what do they have in common? A W. So what am I left with? U minus 3V. I divided positive 18 by a negative 6. That's where that negative 3 came from. So now, guys, do you have two parentheses that are exactly the same? Yep. So that's your new GCF. I'm going to write it out in front. And then what happens with my leftovers? They get their own parenthesis. Could you write the U minus 6W first and the U minus 3V second? Sure. Sure. Now I'm going to do this one of two ways. When I see this problem, I don't like the way it looks. How many of you like things to be in order? Just makes better sense. Fine. I personally would rewrite this. How would I rewrite it? Negative 8x squared plus 6x plus 9. All right, you just have to be careful with signs when you rewrite. What did I tell you? If we're leading with a negative when we're factoring, what should we do? Take it out. All right, so I'm going to right away take out a negative 1. I'm going to be left with 8x squared minus 6x minus 9. You guys agree? Okay, so I have a trinomial, A times C. What are the factors of negative 72 that multiply to give me negative 72? Yep. What kind of 6? What kind of 12? Positive 12, negative 6. Again, you could do the grouping method if you want to. I'm going to keep using my term. So this right here, my A term is not 1. It's 8. So what do I do with that 8? I'm going to, what? Talk to me. Yeah, I put them backwards. Sorry. Thank you. So what do I do with my 8? Divide both by 8, right? Now, are either of these going to divide out beautifully? No, but will they simplify? Yes. What can I divide 12 and 8 by? 4, right? So 12 divided by 4 gives me 3, and 8 divided by 4 gives me 2, okay? What about 6 and 8? 2. 6 divided by 2 gives me 3. 8 divided by 2 gives me 4. So what happens with my denominators? Where do they go? They become the coefficients. So I have negative 1. It didn't go anywhere. That negative 1 is still there. So it's 2x minus 3. You guys agree? And this becomes 4x plus 3. Now, if you did not rearrange, Luke, did you rearrange it?
Yeah, but can I like put the negative 1 with the 4x plus 3, or either one of the parts? Okay.
Did anyone factor this without rearranging it? Because we can, right? We can still multiply A times C, correct? And get what? Negative 72. So what are the factors of negative 72 that are going to multiply to give me negative 72, but add to give me 12? No, just kidding. 6.
Positive 12 and negative 6.
Okay, so positive 12, negative 6. Notice I put the constants in the front. Why did I put the constants in the front? Because the constant is where? In the front. So what am I putting in the back? The x. So your parentheses will look a tiny bit different. The signs will just be different because they're in a different order. That's it. You can still do this the same way. My A term is not 1, so you divide by 8. You'll get the same thing. I just personally like things written in standard form. Just me.
If you don't take out the negative 1, will the answer still be correct?
You'd have to, so did you factor it with negative 8?
Yeah.
Yeah, that's fine. Some people just don't do well with that. But yeah, you get the same thing. You can't just like pretend it's not negative.
No, I mean like your answer is negative 2x
Yeah.
plus 3
Mhm.
instead.
That's the same thing. Because look,
Yeah, 'cause you-
it's the same. It'd be the same thing if you multiplied it in. All right, let's do a couple more. 21. All right, I'm going to talk to you about some different patterns and stuff that we need to recognize. First thing we look for is a GCF, right? If there is one, take it out. This one does not have one. So this is a trinomial. Generally, we multiply a times c with a trinomial. I am going to tell you to get into the habit, guys, of checking to see if it's a perfect square trinomial. Because sometimes you guys, some of your problems, you'll multiply a times c and you get a really big number. And then you think, oh, this doesn't work, or I have to use the quadratic formula. Sometimes the perfect square trinomials present themselves to be very difficult, and you're like, this can't be factored when you just are missing the pattern. This one is easy to factor. But I know on other questions, I'll try and find one for tomorrow to make sure that we go over something like that. But I want you guys to see, yes.
Do you want me to write on the test or a quiz the same thing times itself or the same thing squared?
Doesn't matter. However you want to write it. Oh, we'll talk about that in a second. I don't know why I have number 17 twice. I didn't mean to. So let's, yeah.
Why isn't it 49 y squared?
It is. Just, I'm sorry. Let me finish talking through what I was saying. Give me 1 second, Dylan. It doesn't matter how you write it. I'll show you in a minute. But guys, how to check if something is a perfect square trinomial. You look at the first term and the last term. Are they both positive? Yes. If it's a perfect square trinomial, the last term will be positive because when you square a number, what does it become? Positive, okay? So what times what gives you x squared? X and x. What times what gives me 49y squared? 7yn, 7y. How do we check to see if this is a perfect square trinomial? You take the first term, multiply it by the second term, and times it by 2. What is x times 7y? 7xy times 2 is 14xy. This is a perfect square trinomial, meaning you'll have two parentheses that are exactly the same. What's in the front of each parenthesis? X. What's in the back? 7y. And what sign goes in the middle? Minus. You can write it like that, or you can say x minus 7y and x minus 7y. A lot of you on your test did something similar to this and then told me x plus 7y, x minus 7y. That's different to perfect squares. Where you multiply them together, the middle terms will cancel. A perfect square trinomial, that middle term is doubled of what is in the parenthesis. Not that they cancel out. That's the difference there. You guys with me? A couple more. Look at 24. You want to get in the habit of always checking to see if it's a perfect square trinomial? Try that, right? There's no GCF, right? So let's just see real quick. Is this one of those perfect square trinomials that'll be real easy for me to look at? Well, they're both positive. First and last is positive, so perfect. What times what is going to give me x squared? X and x. What times itself will give me 34y squared? It's a decimal. It's not going to work, right? So this is not one of those perfect square trinomials. This is just, I have to factor it normally. So I'm going to say a times c. What times what, guys, will give me 34 when I multiply, but a 19 when I add? 17 and 2, right? 34 is 17 and 2. Those are not too big of numbers for you guys to handle. So think about what my parentheses are going to look like. What letter is in the front of each parenthesis? X. What letter is in the back of each parenthesis? Y. You have to have both of them. Does it matter where the 17 and where the 2 go? No. What matters? That they're both what? They're both what? Positive, because 19 is positive. Take a second and go 17 times 2, 34, positive 34. 17 plus 2, positive 19. Good to go. Yeah.
When you do the first step, when you multiply a times c, do you only multiply the coefficients and not the variables?
I mean, you can multiply the variables because it's going to be one of each. If you need to remind yourself, I just always just do the numbers because the factors are what I'm looking for. And I know that x is going to go in the front, y is going to go in the back. Whatever square in the front goes in the front of each parenthesis, and whatever square in the back goes in the back. And when you multiply them together, you'll get that middle. All right, here's one that I don't want you guys to get stuck on. I don't want you to just assume. Is there a GCF? No, okay? So I look and I'm going to be like, well, let me just check to see if this is one of those perfect square trinomials. Is 4x squared a perfect square? Yeah, is 25y squared a perfect square?
Yeah.
Yes, what's the problem here though?
They're both minuses.
This is the 4x squared is not negative, but the 25 is negative. Right there, that should tell you, oh wait, this isn't one of those special patterns. But say you don't see that. Say you're like, oh yes, so easy. This is going to be 2x and 2x, right? This is going to be 5y and 5y. How do you check at this point to see if it's a perfect square trinomial? You multiply 2x times 5y, which is 10xy, and you multiply that by 2. Does 5 times 2 times 2 give you 15? No. So this is not a perfect square trinomial. This is where you got to go old school. A times C. What is 4 times negative 25? Negative 100, okay? You can do this the grouping way or the Meadows way, whatever you want to do. What is going to go in the front of each parenthesis? X. What's going to go in the back of each parenthesis? A y. What two factors of negative 100 will multiply to give me negative 100, but add to give me a negative 15? Perfect. Negative 20, positive 5. So I'm just going to put negative 20 here and positive 5 here. What do I now have to do with my a term? Divide both of these by the a term. What's 20 divided by 4? So I have x minus 5y. What happens with 5 over 4? 4 becomes the coefficient. So 4x plus 5y. Now, if you want to do it the grouping way, no problem. I'll do it over here so you guys can see it. So I have my 4x squared. I have minus 20xy plus 5xy, and then end with your last term, minus 25y squared. So when we group first two, second two, what can I take out of 4x squared and negative 20xy? What can I take out of that first group? 4x. Agreed? Okay, so I'm left with what? X minus 5y. Okay, what can I take out of the second one? Positive what? 5y, okay. And I'm left with x minus 5y. So what's your new GCF that presented itself right here? X minus 5y. You write that one time, and the leftovers get their own parentheses, which is 4x plus 5y. Same thing. Either way you guys want to do it. Does not matter to me, as long as mathematically it makes sense. But remember, as soon as you are done with a problem, if you want to check it real quick or wait till the end, just go back and foil it through. You should get the original problem that you start out with. So what I'd like you to do tonight, I did a bunch of problems here. There's more of these, 1 through 30. There's a video in the assignment of Ms. Ferrier working them out. Come to class tomorrow and say, hey, I didn't understand this one. I have a question about that, whatever. I'm going to give you a test back tomorrow. I'm also going to do a class kick with some extra problems to work on. And our quiz will be on Thursday. Everybody good? Okay, thank you.